was going to cover sort of like the dplyr package in R and some related stuff in the tidyverse. Um, Basically, I think mostly we'll be talking about like manipulating data frames in a sort of tidy data and doing that with tidyverse functions, mostly dplyr. And so that's sort of in contrast with like, I think most people, when they are coding in R, they start out using base R functions. And then there's sort of this transition that you can make to the tidyverse style of code, which I think is definitely, it's like there's a learning curve, but I think it's definitely worthwhile. I know some of us in Leo's team use dplyr and tidyverse all the time, but maybe others don't as much. So today I'll be reading through this resource from Rafael Irizarry. So he has this data science online book that's free. So it's a great resource. And I'll be reading from chapter 4 here. So basically, in terms of installing packages, if you want to follow along, you can install tidyverse, which is actually not a package. It's a group of packages, of common packages that you'll need together doing these type of analysis that we'll be talking about today. There's also, it's not really mentioned until down here, but there's like this DS Labs package that includes like a data set that we'll be working with today. So those are the packages. And basically, I guess we'll just get started. So the first point that he makes in this book is just talking about tidy data. So this is like, basically data can come in a lot of different formats, and the format called like tidy format is really easy. It's really easy to work with. I think it's hard to explain exactly why it's maybe favorable to other formats. One of the key reasons is that it just allows you to work with this group, the tidyverse group packages, and in particular ggplot. If you have tidy data, you can work with ggplot very cleanly. Otherwise, you may have to reformat things. So tidy format is basically when you have a data frame and each row is an observation, and then columns are like different variables representing something about that observation. So he gives the example of this murders data set where each observation is a state. And so you have information about the state, its abbreviation, where it is in the country, the population of the state, and then the total murders. I'm not sure when this was done, but presumably it's like a year maybe. But in any case, that's the idea, is that you have each row is an observation, essentially. So I'm going to skip a little bit down to an example of something that's not tidy. So this data frame here has like fertility rates for different countries and different years. And you'll notice that like each row is not an observation, or at least like really the data is the fertility rate. And you have that in 3 different columns by year. So the years are not really types of variables. So I guess in contrast, the tidy format is a little bit above this right here. So each row has you have the variable for country, year, and the fertility rate itself. So each of those is like an observation. And again, this tidy format will allow us to work with tidyverse packages, including ggplot, and it's really much cleaner to work with. And so, yeah, it's hard to say exactly why. You get a sense with once you work with this type of data more that it just ends up cleaner if you have this sort of format. So I'll move down a bit. Oh yeah. Sorry for that. So there's some exercises that I'll mostly skip through in terms of like whether data is tidy or not. It is important, but I guess for today we're starting a little simpler, and we'll mostly focus on data that's already in tidy format and just how to use dplyr and stuff with data that's already tidy. So I'll skip through a bunch of this, and we'll get right to dplyr itself. So we'll be working with this murders data set, like I mentioned above. And the first function that they introduce is mutate. So you might be used to the $sign syntax, where if you're adding a column that's called murder rate, or called rate actually, you would just do like murders $rate equals murders total divided by murders population. So there's a couple differences already here. So the first maybe weird thing that's different than base R is that you have these variables called total and population that are not defined yet, or that's what it looks like, right? So the interesting thing about dplyr and tidyverse functions is that you provide the name of the column unquoted, and it will refer to the basically that column, the current value of that column. Now, later, that'll become obvious why this is maybe an improvement over quoting variables, but for now, just know that these are, when you're working with names of columns, you don't put quotes around them when you're working with dplyr and tidyverse stuff, including the new column name itself. So that's already one difference. So yeah, that's one function. Right away, it's not obvious why you should use this instead of base R, but we'll keep going. And I think that'll become more clear as we go on. And so, yeah, we add this column called rate, and you can see it down here. So basically just like the number of murders per capita, I guess, is the interpretation here. So let's keep moving on. We'll go to other functions. I think the next one, another very common function here is called filter. And so in base R, if you're trying to basically filter by row, you might do, actually, maybe I'll type this over and let's actually do this interactively to show the difference. So I'm going to, I have this over here. I'm gonna open up, let me just load murders data set and these packages. I'm gonna move down now. So we'll add this rate column like they did up here. And then, so yeah, that's the tidyverse or the dplyr way of doing things. So just as a comparison here, we'll have the base R version times. All right, so those are doing the same thing here. So this is mutate versus base R. So now we have the filter version. So we have filter versus base R. So what is this line really doing? We are filtering the data frame. So we're taking all columns of the data frame, but we're filtering by rate less than 0.71. So this is what it would look like in base R, right? What did I do here? Did I not? I didn't define the column yet. I think I defined it here, but then I never actually ran this line. So this gives us, let me know if this is too small, by the way. I was trying to get the size right here, but yeah, so this will give us like the states with a rate below, a murder rate below this 0.71. And then in dplyr, we use the filter function when we're filtering rows. And so you provide the column name and then basically the condition. Again, no quotes around this rate variable. So this should give us the same thing. So mutate for adding columns, filter for filtering by condition, filtering rows by a condition. Next, there's select, which is basically filtering columns or selecting columns. So let's do the same thing here, how this might look like in base R versus dplyr. So we have, I'm just going to print this directly to the screen. So just to show what this looks like. Actually, you know what? Another thing I think is worth mentioning is that, like, I don't know, I personally get tired when I'm working with data frames. I like just try to look at the data frame and it prints like 100 rows or something. Like it just annoys me. So for that reason, I prefer tables. That's one of the main advantages, honestly. If nothing else, like, is just you can convert a data frame to a table, and then it'll print nicely. It just prints the head by default, which I think is just a much better, much more sane default than printing thousands of rows potentially. It also gives you the data types of each of these columns, which is kind of useful. So we can see which things are factors, which things are population for some reason is a float instead of integer. But anyways, just clean printing data types. And then one other thing that's I'd say is different about tables is, and this may be like counterintuitive at first, but you're not allowed to have row names. The rationale behind that is that row names are really like a sort of an artificial addition to data frames in the sense that they really should just be another column, right? So if you have observations and you have different variables, row names are just a variable defining for each of your observations. So it really should just be a column. So that's why you're not allowed to have row names, which also becomes more natural to work with, I think, once you get used to it. But anyways, that's sort of a side note about tables over data frames. And so we'll get back to select. So select, notice how we narrow this data frame as I type this. So we're taking the data frame and then we're again typing column without quotes. There's a couple of different ways you can do this. You can do it like this. You can also put it as a vector. a single vector, and that works as well. But so yeah, in base R, you probably already can see how this would be done, but we do it like this, right? You're using the subset by column here. So we introduced 3 different functions so far, and there are some exercises here. I'll probably move on and just show an idea of like more ways to use these functions. So I guess the next thing that you'll see in this tidyverse style code is that while we've introduced these functions where you provide the data frame in the function and then you provide whatever the next argument is, in this case, the condition, when people write this code, often they'll be actually using piping a lot. So previously, the pipe actually was a feature of the tidyverse. I think it was this macrodar package, but they introduced the pipe in base R in 4 point something. Actually has it right here, 4.1. So you can really, this is not an aspect of the tidyverse necessarily anymore. You can use it with any functions, but they show an example of like combining what we've done so far using piping instead. So let's just make this a little bit more clear here, what's going on. So I guess to just describe, right, we're selecting some columns from this murder's data frame. Then we're filtering rows based on this condition of the murder rate being below a certain value. So just to make this crystal clear, we'll go back over here and compare this to base R again. When I format this, I tend to format things like this, where you have a tab after the, well, really 4 spaces, but you know what I mean. And each operation is its own line. I think that just looks a little bit cleaner. Anyways, so let's do this without pipes. We'll be using dplyr but not pipes. So really, you would do whoops, not this. Select, and then we put the first argument murders in, right? And we would keep assigning. Now, this might look natural if you're used to base R, where we keep assigning a new value to the data frame in each line. Right, so those are the 2 versions. Without piping, we're providing murders as first argument every time versus skipping that first argument and we're piping. So I guess the advantage here is that, I mean, of course, one small advantage is you don't have to type as much or make as many assignments. But also, I think it just makes cleaner code in the sense that you can describe a series of transformations as different functions in the order that you naturally are applying them. And so, yeah, I guess that's the pipe. I don't know if I explained that very well, but let's go back here. They go on to show that, like I mentioned, this is not a dplyr or tidyverse thing, although I would say it's like pretty correlated in the sense that most people who write dplyr or tidyverse code are going to be using pipes very frequently. But they show, like, even with base R functions like square root, instead of doing square root of 16, you could do 16 pipe square root. Not that you necessarily should do that, right? And I think usually you would do square root of 16 here. But there's some cases where you could argue the ordering of the functions makes more sense if you use pipes versus if you have a large series of operations that you're doing. Sometimes it makes more sense to describe the operations in order, which the pipe allows you to do, versus doing like, I mean, this isn't a great example for this, but like the alternative would be like log2 of square root of 16. And so the order sort of goes like from inside to out, right? Let me describe what I mean there. So you could describe it with pipes here, or you could do log2 of square root of 16. And what I mean from inside to out is like the first operation is in the inside, and then it goes like right to left. And when you have a large series of operations, maybe piping can make it more clean, more logically organized in some sense. So yeah, piping is pretty useful here. We'll go into more examples of when it really becomes a lot cleaner. I guess the next thing we can do is we'll talk about summarizing. So the idea behind summarizing is you're applying some operation across many rows. It doesn't have to be all the rows of the data frame, but we'll start out with doing summarizing all the rows. They do switch data sets here. Now they're working with a heights data set, different heights of people. And they give this example. So we see the filter function again. So we're taking this heights data frame, we're filtering to females. And then when we apply the summarize, we're doing a couple of things here. We're actually defining two new columns. So this might remind you of mutate, right? Where in mutate, we're adding columns just like this. The difference between summarize and mutate is summarizing is applying across multiple rows and then returning a smaller data frame. In this example, since we're applying across all rows, we end up with one row after we summarize, and then the two new columns that we added here, average and standard deviation. So we're taking all females and we're finding their average height and the standard deviation of their height. That returns one row. So yeah, just they make the point here that it is a data, like the data frame. Actually, it might be a tibble, but I think it's a data frame. Anyways, they return a data frame so you can access the variables just like you would any other data frame, the $sign syntax. So you can do much fancier things with summarize, and we'll start to touch on that in a bit, but yeah, for now, summarize will be applying across all rows. So just going through here. Let me see if this is good introductory material. I think this is more complex use, so I might skip over this and go straight to grouping. So grouping is one of the big things that I think is just much easier with dplyr tidyverse than it is in base R. So we start again with this heights data set. So you can use this group by function. So we're grouping by sex here. And by itself, this function does nothing except really when you print, it'll show that you have two groups, but actually it's printing the full data frame, a tibble, right? So that's why it's printing only the first 5 rows. So group by itself doesn't really do much until we combine it with other dplyr functions. So sort of similar to the past example, where before we had filtered to just females, and then we're summarizing basically all rows. This time we can actually, since we have two different sexes in this data frame, we can apply the summary across both. So that's one of the uses of grouping by. So we're grouping by sex, and then we're summarizing within those groups. So you can find the average female height, average male height, and the standard deviations for both of those. So this would be a little bit more annoying in base R. Although with 2 groups, it's not too bad. I think the main benefit comes with when you have a huge number of groups. You don't want to, I mean, you could write a for loop and stuff like that, but this is maybe a little bit simpler. So yeah, I think the most common functions you'll see with summarize are like often you're computing a mean across all the rows or a standard deviation, or sometimes the max or something like that. So, okay, that's summarize. We've gone through a good amount of functions. So definitely let me know if anything's unclear so far. Otherwise, I'll get next into the poll function. So far we've been talking about functions that operate in data frames, and then they generally return a data frame. So poll is when you want to grab a vector out of a data frame. So let's see if these examples are. Yeah, I guess they show an example of when you use it with summarize. If you're trying to grab basically the column, the actual value. So first they go through the murders data frame. We're actually going across all the rows this time to find the total murder rate across all states, which is a single value. But if you just do these first 2 lines, it'll return the data, or actually, I might as well do this actually just to show you, but it returns a tibble, right? So it's a single value, but it's returning a tibble, and maybe we really just wanted to return the value, right? So that's one of the uses of poll, is that it takes one of the columns and it turns it into a vector. So that's almost like applying the $ syntax, like $rate in base R. So yeah, pretty simple there, but allows you to convert back to vectors when you need those. Keep going. I know I'm going through this pretty fast, but trying to get like a general sense of what tidyverse and dplyr are like for those who are less familiar. So you might also wonder how to sort data frames. So that's like a common thing. You might sort by a particular column, and like the order and sort functions exist in base R. But arrange allows you to work with the data frames as a whole. And so in this example there, we're doing something pretty simple. We're taking the data frame, we're applying this arrange function, arranging by the population column. So that just means like we're sorting by the population column. So the first row is going to have the smallest population by default. You can also surround this in like desc. I'll show you in a second. So murders arrange gives us population smallest to largest. You can wrap this in desc like this, like descending, and then it does the opposite where we have California, like the most populated state here first. So that's just like a little note that you can do there. And then let's see, you can, of course, you can sort by other things, like you can sort by rate to see which state has the largest or the smallest. In this case, this starts with the smallest murder rate, which apparently is Vermont. Oh, they do mention this desk here, so missed that. But, so you can do them more than just arrange by one column. I introduced nested sorting here. So note that you have two column names here. So what that means is that we first sort by region and then we sort by rate. So they say that like this is, you can break ties using this strategy. So we're first, you see the region is starts out all northeast, since that's the first thing we're sorting by. But within northeast, we're sorting by rate. So that since all these are northeast, you'll see that the rates are increasing here, strictly increasing. So they note that here they use the head function to get the first rows, but you can actually do this instead of using head. You can use the function top n, I guess. I really don't use this function. I use slice head, but I guess this is an alternative where we're just taking the top 5 rows. In fact, I'm actually not clear why we can't just use head here and then just do n equals something else if we need a different n. So that's a little bit unclear to me, but I'll introduce, so instead of this top n, I want to describe like the slice head. This is what I was talking about. You can choose how many rows, and it's a little bit different than just doing, actually that's probably the difference, is that these functions work with like grouping and other things that where head probably, it might not, actually it might work, I'm not sure. In any case, you can use this slice head function to take the top number of rows, or you can even do proportions here. I think you can do like, let me make sure I got this right, like the top 10% of rows, which apparently also is, oh, right, because 50 states, okay, that's why. Just got a little lucky there. So let's go back here. And so I think that was most of the content here. I'll go just a little teaser of like maybe more complex things you can do here. I have a script here. And so again, starting with this murders data frame, if we're just asking, so we're looking at this murders data frame and we want to find the top 3 states by murder rate. Actually, let me reload this so we can start from scratch because we don't have this rate column. But yeah, what are the top 3 states in murder rate by region? So there's a couple things we can do. I guess, actually, let me just start with showing how you might do it in base R. So I think it's a little awkward looking in comparison to using dplyr and tidyverse. But first, I always turn things to a table just because I prefer that, not strictly necessary. We can define the rate column like by combining the total and population columns. To sort by the rate column, you can use the base R order decreasing equals true so that we get the highest rates first. And then the annoying part here is if we're doing it by region and there's multiple regions, there's a way to do this in base R. So what I would do is I would just do a for loop through each of the regions. This is like a common pattern I do where I make a list of data frames and then I use do.call and rbind to combine them. But anyways, if you're doing this by group, we can first filter to the region and then take the top 3, since that was our objective at first. And so let's do that. And then if we're only interested in a few different columns, we would subset like this. And then we would end up with basically just the states, the region, and then each of these is sorted by the rate. So we have the top 3 states by murder rate for each region. Apparently Maryland is on here, which is not great. So that's base R.
It's not in the south, no?
Yeah, I don't know why it says south. I mean, we're sort of right on the border of, I would think we would be like east or something. I don't know. That's kind of weird. So a little bit, I don't know. I think this is kind of like clunky, base R. So we can do this in dplyr without the piping. So if we're first adding, just to review what we're doing, we're first adding this rate column based on the total and population. We're grouping by the region. Actually, this arrange could have been put before the grouping since it doesn't really matter. It's not different, but we're sorting by the murder rate in descending order for each of these regions. Then we're taking the top 3. Finally, we're selecting only columns that we're interested in. And then groups, not strictly necessary, but it's sort of like a best practice to make sure that if you're doing stuff afterward, you're not accidentally grouping when you don't need to be. So we can do all of this and this would end up the same as, actually not identical. I guess the order of the regions is different for some reason, but not quite sure why that is. But in any case, we're still achieving the same functionality. We're taking the top 3 murder rates for each region. And then finally, I think this is sort of the way I would do it, and which is we're using things we learned with dplyr and we're using base R piping. So same sort of, really the same structure as this no pipe version, but not typing murder df like many times. And so, yeah, that works well. And yeah, there's more functions. I mean, I think this covers a lot of the functions that you might use, some of the more common functions. There's more, but honestly, just these functions alone can get you pretty far. I use this every day, so I think it's worth learning, worth trying to get into if you're used to base R only. And that's all I had for today.